Hey guys, we're going to look at properties of logarithms today, and it's got some great things we can use that help us to solve logarithms that should tie into our previous lesson, so that's a good thing. These properties right here are the main properties that you will need, and we've got the product property of logarithms, which says if you multiply two numbers together, you can separate them by addition. We have the quotient property, which says is if you divide two numbers, you can separate them by subtraction. And the power property says that if you have an exponent, the exponent comes to the front. So exponent to the front. Product property, separate by addition. And quotient property, separate by subtraction. All right, so how can you prove the property of a logarithm? Let's say we let x equal log base b of m and y equals log base b of n. And b to the x equals m and b to the y equals n. And that's by your converting from a logarithmic property to an exponential property. So we could say b to the x times b to the y equals m times n. And since we have like bases, we can add our exponents. And if we rewrite in logarithmic form, then we would get x plus y equals log base b of mn. And then we substitute. You know that x is log base m, log base b of m, and we know that y is log base b of n. And that equals log base b of mn. So we've just proven a property from above. You're not going to have to be in charge of proving things. I just wanted you to see where it came from. All right, so how can you use these properties to expand? So all we do is we recognize we're multiplying two things together. So I can separate those by addition. So I can separate that as log base 5 of a squared plus log base 5 of b to the 7th. And then I have exponents here that I need to deal with, and those exponents can come to the front. So my final answer would be 2 log base 5 of a plus 7 log base 5 of b. And that's your final answer. You're just separating logarithms using their properties. Same thing for b. We're dividing, so when dividing we use subtraction. We can just write this as ln of 25 minus ln of 3. And that is all we can do there. Well, we could take it a step further. If we wanted to even go a step further, we could write this as ln of 5 squared minus ln of 3. Then we have an exponent that we can put in the front. So 2 ln of 5 minus ln of 3. And I'm only showing you that because I can't remember if your homework has one where you need to simplify a square or a cube so the exponent can come to the front. But you take note that you can rewrite that with an exponent and it can come to the front. This last one, we have three properties. So log base 7 of r cubed plus log base 7 of t to the 4th. Then I'm going to say minus log base 7 of v, because this is being divided, so we have to subtract. Then bring all your exponents to the front. 3 log base 7r plus 4 log base 7t minus log base 7v. Okay, and that's as simplified as you can get. Okay, the other way we can do this is we can put things back together. So we can condense logarithms, which means put it back together as we saw above. So we're going to write it as a single logarithm. Okay, so when you do that, start with the exponents. We would have log base 4 of m to the 4th plus log base 4 of n cubed minus log base 4 of p. And if I want to write that as just one logarithm, I put my log base 4 here. I have a plus sign, so that means m to the 4th times n cubed, and I have a minus sign, which means divided by p. Okay. Same thing here. Start with the exponents. We've got ln 2 cubed minus ln 5 squared. So this minus sign means we're being divided, but we can go ahead and make this ln 8 minus ln 25, and that means division. So we have 1 ln 8 over 25, and we're done. So the idea when you write as a condense, you single logarithm, you only have one logarithm in there. All right, and then we just have a basic example of how could we use this and where does this come into play in real life, because I know that's everybody's favorite question. So the pH of a solution is a measure of its concentration of hydrogen ions. This concentration, measured in moles per liter, is given by the formula. And here's the formula. What is the concentration of hydrogen and ions in the acid rainfall? So acid rainfall over here, we have a pH of 4.5. So we can just say 4.5 equals log 1 over H plus. We are going to use the quotient property here and separate that. So 4.5 equals log of 1 minus log of H plus, because we can separate those. Okay, so log of 1 is 0, so we're just left with negative, well, we'll leave it as 4.5 equals negative log H plus. Okay, and then we want to get rid of our negative 1, so we'll leave it as negative 4.5 equals log. And remember, this is implied log base 10 because there's nothing written there, so it is implied log base 10. And then rewrite exponentially and you get 10 to the negative 4.5 equals H plus. And when you put that in your calculator, that is about 0.00000316 moles per liter. And that's your answer. So that's using the properties to solve basically a chemistry word problem, but it definitely works. All right. How can you use base 10 logarithms to evaluate base 2 logarithms? All right, so we would need to reevaluate this as base 10. But instead of proving it, I'm just going to go ahead and give you the change of base formula, which is going to be really helpful. And what the change of base formula says, if you have a log b of m, so some log base that's not 10 that you can't use your calculator for, you can rewrite this as log a of m over log a of b, and then use your calculator, because your calculator will not do things that are not in log base 10. So for example, if we had log base 2 of 3, like the problem stating, a log base 2 logarithm, we could just rewrite that as log 3 over log 2, put that in our calculator, and we would get approximately 1.585. 5. So anytime you need to use or find a logarithm that's not base 10, you use the change of base formula. So same thing here. You would just have log 7 over log 2. Put that in your calculator. You get about 2.807. And for this one, you would do log 3 over log 5. You get about 0.683. So that's the change of base formula. Now, what is the solution of 2 to the x equals 7? So, 2 to the x equals 7. Let's rewrite in logarithmic form. So x equals log base 2 of 7. Okay, and then you can use the change of base. So you would just get x equals log 7 over log 2, which is about 2.807. Okay, so you can do the same thing here. 3 to the x equals 15. We would just rewrite that as x equals log base 3 of 15. And then we'll rewrite that using the change of base formula, which would be log 15 over log 3. Put that in our calculator and we get about 2.465. All right, so take your time, look over these properties. Here are the rules. It will come in handy. And what you're gonna do next is you're gonna do a practice worksheet with a partner. Over the properties. Of logs. So find someone to work with and see how it goes, and then you guys will check over this when you're done. Hope you're having a great day.